In this ProteusDS training session, we're going to go through fundamentals of working with the cable dynamic object. Brief agenda, we're going to go through some terminology in terms of nodes, elements, and segments. We're going to go over material properties, that's the decable segment properties, in more detail, talk about some loading features like XMass, look over some results, setting up connections, and an example simulation with a pendulum. When we talk about the cable model, we often talk about nodes and elements. That is a finite element model, and the structure of the cable is built of lumped masses of nodes, node 0 at one end through to node n at the other end. The number of elements is often configured directly by the user, so hence the number node n and element n. Elements are bridge the spacing between the nodes, and groups of elements are called a segment. Segments have the same material properties and physical properties. A segment may have one element, and it may be the whole cable. Now we're going to talk about setting material properties. We use this with the decable segment feature. These are all the physical properties of the elements, and really common properties that we cover are things like the normal drag coefficient, the tangential drag coefficient, added mass coefficient, axial rigidity, flexural rigidity, diameter, and density. Material properties can be found in official parts libraries that are set up to work with other ProteusDS tools to make this really easy to work with. There are parts library editor tools that you can use to read information off commonly found spec sheets and automatically create these properties. There is also a cable properties wizard beta utility that can be used to help configure these properties, although this won't be supported in the future. To find the beta utilities, for the moment, you can go in ProteusDS Simulation Toolbox, Help, and visit Beta Utilities page, which will open up in your browser. And there's the Cable Properties wizard. Additional guidance on how to calculate the properties yourself directly can be found in the manual under Cable, and then guidance on specifying cable properties. This is a view of the cable properties wizard where you specify the diameter and other properties like breaking strength, and then it'll generate the properties that you can copy and paste right into the decable segment property. So we go to Add Feature, Decable Segment, My New Segment. You can paste in the properties here. We're developing new tools like parts library editors that are easier to work with compared to the cable properties wizard, and this is another way of generating these properties. And then the parts libraries are used by other ProteusDS related tools to make it easier to set up these parameters. These are properties you might see on a typical spec sheet. This is Samson rope AM steel blue, and there's no standardization of any of spec sheets across manufacturers. There's specific gravity, elongation at 30% of breaking load, and the line properties with 3/4 inch diameter. There's a minimum breaking strength, diameter in millimeters, weight per 100 meters, and so on. These are what you need to know in order to specify the properties of the line. All cables have a state. So there's state information in the manual for each D object as well. In the case of a cable, the state of the cable is a node position and velocity for all nodes in the mesh. In addition, the unstretched element lengths need to be specified. when we create a cable, the cable state generator helps us specify the geometry of the line in terms of the total length, node 0 and node n positions. So if we go to edit properties, we can see we can change the geometry length, the absolute x, y, and z location, height above seabed if you want to work with the custom bathymetry, the node position, and then also instead of directly specifying the node n position or node 0 position, you can specify the relative locations and even an azimuth angle, which makes it a little bit easier to work with, setting up spread moorings, for example. Once you've got the geometry set up, then you apply and specify the number of elements and the unstretched lengths for those segments. Depending on the material properties you've got loaded in the library, you can pick between them. Segment 0 just means default material properties. This is a view of the cable state generator we were just looking at. Now let's set up a basic pendulum. So this cable will have a length of 23 meters. We'll leave node 0 at 0, 0, 0, the global frame surface. And we're going to specify the other end to be at 10, 0, and 20. So we'll put it down 20 and go OK. Now the unstretched length doesn't match up with the geometry lengths, so it's giving a warning just saying, hey, there's going to be a lot of initial stretch. You've got to resolve this. So we'll click on resolve here, and you can see it's changed the length of the segment to match up with the geometry. We're going to specify 5 elements, and we're going to go OK. We need to make sure we set node 0 static to 1. That's going to pin this node in place. And then we'll go down and add an XMass. There's 2 ways to do this. You can directly type it in, but you can also go XMass this way. And you can leave the name the default, or you can directly specify weight, for example. I'm going to go to feature definition. It's not in the library, so I've got to create it. And we're going to specify the density to be 2000 and leave the other properties the same. Let's check it out in the visualizer. So we've just got this little pendulum on the side. Oh, it looks like the XMass is at the top here, so let's change this to be at 23 meters along the span. There, that's better. You can see it down here on the end. Okay, and we'll run a basic simulation here to see what happens. We'll call this project pendulum. Let's load the results in ProteusDS. Okay, now when we hit play, there's a bit of a transient while the system is shaking out and damping out some of the initial effects there, and it's going to slowly go back and forth like a pendulum. You can see a color plot of the tension in the line as well. An engineering view, show a little bit more clarity in the elements. So now we're going to reset the simulation. And we're going to duplicate this D-object so it makes a copy. And we're going to change this to, we'll leave the name appended as new. And we're going to offset it by 5 meters in the y direction. You can see now we have a completely new copy of this pendulum. We did show a connection, a way to connect cables to other things and increase the sort of interaction you can have with them. Instead of using an XMass on this new cable, by deleting the $sign, it deactivates this property. You can see that it's no longer got a weight on the bottom there. We're going to use a PointMass instead. We'll leave the PointMass as the same. The dynamic model is almost exactly the same for a PointMass as an XMass. One option we can do here is we can specify all the properties directly. We can also copy the XMass feature properties that are used elsewhere, so this way it's just a faster way to set it up. And then if you right click on this and go use existing feature, you can see, well, we've already got weight set up in there. Now the only thing is we'll have to set the state of the PointMass to match up to where the bottom of the cable is here. So this is 10, 5, and 20. Generate. So you can see we've got our PointMass lined up with the new cable, but we've got to make a connection between the two of them. The only way to make this kind of connection is with PointMass as a master, the new cable as the follower, and there's only one kind of connection type available, point. There's one connection setting to differentiate which end of the cable it's connected to. It's saying decable follower node N. Yes, we are trying to constrain decable follower node N. And let's run the simulation. Note I left the ProteusDS window open. Now it still has the old simulation data in memory. This is a shortcut though. There's a reload button here which quickly attempts to reload the data in an updated simulation. So let's click on that. Now you can see we have two pendulums, including one with our PointMass here on the end. And if we just kind of let them play back and forth, you can see we basically got exactly the same dynamic effect. So this is just a way of showing how to make a connection between cable and another kind of the object. We really wanted to focus on some key concepts of restarting a simulation, which we've done. You can make a brand new simulation by exporting the final state. And this will make a brand new project with the starting. The starting position is the end state of the last simulation. So we might want to do something different in the simulation, bridging off where it ended off. But we already reset a simulation. We made some changes to it. We made some connections. If you look at the results output for a cable, some key output files are here, including tensions.dat. You can visualize these in ProteusDS, but this is showing the time history and then the element tensions through time as well. So there's lots of data there, as well as the results, the XMass properties, the position of the XMasses through time as well. Take note the tensions are the average over the element, so the size of the elements will start to have an impact on how much information you can see in the results. So just to review, we went through some terminology, nodes, elements, and segments. We talked about segments and the material properties and where to get some information on that and guidance on that. We looked over some results and made some simple connections between different objects, the cable and the PointMass in this example, and played with a couple of pendulums. Thanks for watching.